Right. So welcome everybody. I'm just checking the number of participants. Hopefully we get a couple of more. But yeah, so welcome to the OneClick LCA Building LCA training session organized as part of the Saint-Gobain Architecture Student Contest. My name is Maija. I'm from OneClick LCA. I work there as a sustainability consultant and trainer, and I am here today on behalf of OneClick LCA to get you acquainted with the topics of life cycle assessment, theory and practices. So a couple of rules to begin and to bear in mind before we start. So please keep your microphones muted and ask questions using the Zoom Q&A function. So there is also a chat function, but I urge you to use the Q&A. So that is where I will be looking at your questions at some point. So the questions will be answered live during the Q&A part of the session. So that will be at the end of this session. But I also might address something in the middle. And there are also a couple of my colleagues online that may answer your questions during the session as well. So this session is recorded, and the recording and the slides are made available the next workday. So that will be tomorrow on the academy.oneclicklca.com page. So we can check that actually a bit later. But now I see that we are again increasing in number of participants slowly but steadily. So first I would like to give the mic to Timo from Saint-Gobain. So please.
Yes, checking my mic is okay. Yes, perfect. So hello everyone, all the students that are participating in the Saint-Gobain Architecture Student Contest. It has been many years that Saint-Gobain has started this competition specifically for students with the objective that it can give you an experience, a unique experience in a project that is closely related to a real client request. In this case, next year, the contest will be held in Helsinki. So you have all seen the contest asking what is asked. And as we have done for Helsinki, every time we have the competition, we have the municipality and other stakeholders providing a project where students can be as close as possible to real market demands and client needs. I'd like to also take the opportunity to thank our different partners, specifically the University of Helsinki, the City of Helsinki, the Finnish Green Building Council, and all the Saint-Gobain leaders, especially the team in Finland, for helping identify and develop the contest as they're going to be working on for 2024. And similarly, all of the universities and students and professors that are participating. I want to remind you, as probably as you have seen, that in the Architecture Student Contest website, there's a frequently asked questions. Don't hesitate to also post general questions related to the contest there, and also check it because you might see responses that are probably similar to the ones you have had already. Also, via your professors, the contact with the Saint-Gobain leaders to be in the loop of news and latest updates. As Maija was mentioning, today will be the first session of the OneClick LCA training. And this is an important topic for many things. One of them is like a life cycle assessment of buildings. It's becoming more and more important, not only in Europe, but globally. We start to see that many countries are starting to either implement or develop legislation where they include the analysis of embodied carbon at a building level. And that means that you have to put input at the product level. So it's important for you as a future professionals of the construction sector to better engage different architects or other stakeholders, engineers in the design phase in order to have a proposal building projects that have a lower carbon footprint. So it's a way for you to be on top of current trends and to take this as an example of things that you're going to be doing in the future. Also because a lot of building certifications like LEED, BREEAM, among others, they start to integrate more and more this type of analysis in their credit evaluation. So again, this will give you more insights and knowledge on how to address this important topic as you develop in your career. I'd like to also take the opportunity to remind you that the next webinar will be on Thursday. Maya will probably talk more about that. That the replay will be available also in the Architecture Concepts YouTube channel. So don't stay to review it again after you have seen it, in case you need to refresh some of the things that you have seen between today and the next session in the week. With that, I finish the introduction and wish you all the best in this project, integrating these important topics not only into this contest, into this project for Helsinki, but also to integrate it into your other projects as you continue with your professional life. So thank you a lot for participating, and looking forward to seeing what you have done towards the end of this contest journey. I give you back the mic, Maya.
All right. Thank you so much for that introduction. And next, let's continue to the actual training then. So why do we need a building LCA training in this context? Well, we heard quite a lot from Timo just now, so it's very important for you guys to know how to assess a building, or how to do a whole life cycle assessment for building projects and so on. So this course is specifically designed for you as architecture students to give an overview of this whole life cycle assessment term, so what it entails. There's some background, so theory, as well as the practical guidance on how to actually deliver the assessment using OneClick LCA software. So what you will learn in a bit more detail, you will understand the impact of construction sector on climate change, the need for building sustainability, and the regulations driving them. And you will also learn about the core concepts of LCA, including building life cycle stages, environmental impact assessment, and the data required for performing this LCA with hands-on software training. And we will show you how to use the OneClick LCA software and also Carbon Designer 3D, which is our early stage design tool. And what is included? So we are hosting 2 separate sessions on the topics of climate change, construction industry materials, practical life cycle assessment, and optimization. And the next session will be held on Thursday, same time as now. So be sure to attend. So what we offer you is the license to our life cycle assessment software, training, additional materials that will be available for you the entire duration of the course. So the course and the contents will be closed on last day of June next year. These sessions are recorded, and the recordings will be uploaded to the course site next working day, as mentioned. So if you have not yet registered to the course, you can do it also later. It's up to you, but I urge you to check it out. So here, if you click the Academy, you can see the course page. And here inside, if you go into the course, you can see the general information. So here's some info on our sessions, also the links to the sessions, some general rules, but that we also did go through already. What we are providing you in terms of software, a quick intro on how to access the OneClick LCA software, also the license key that you will be using, but I will be showing this in a moment. Some information on the exam and certification. So we are providing an exam. It will be opened on Thursday after the last session. It will be multiple choices. It's something that you can take how many times you want, and you can retake it, as many times as you need to. Once you've passed the exam, so you need 90% of correct answers to pass, you will get a certificate for basic LCA knowledge. So and then an important notice. So your certificate is dependent on these complete and continue buttons. So once you have done the exam, and if you don't see the certificate, you need to check that you have clicked this complete and continue on each page. So yeah, then we have some information on how to access, some help center articles. The live sessions will be, the recordings will be coming here in this section. And also we are providing you this optional self-study materials. So you can also find this free OneClick LCA building LCA onboarding materials in your own language, as long as you're speaking one of these languages. So we have these materials in English, French, Spanish, Italian, Finnish, and German, and I believe the Swedish one is also coming up anytime now. And then we also offer an on-demand course, which is specifically designed for architects. This is only in English. This is, you can click here to register. So it's maybe a bit more design oriented and has a deeper like a look into the topics that you would need to know as architects doing LCA. Then if you're interested more in certifications such as PREEM or LEED, we also have specific trainings for those, so you can click here to find them. And then I urge you to remember our bootcamps. So we have recurring LCA, construction LCA bootcamps, as well as EPD bootcamps. So these run for 5 days in a row and 2 hours per day, and live sessions. And then you will also have these live Q&A sessions included. Yeah, and you can also go to LinkedIn to check out the announcements. And then we also provide you a community page. So this is a space where you are able to connect with other contestants, answer questions, or just share knowledge. You can also post a bit more like software specific comments, as we or I will be checking the page every now and then. So if you go click here, you can see the community. So there's already 104 members, including myself. It's good. So here we have really different space. So if you have specific questions, be sure to post them here in the questions section. And yeah, just bear in mind that we can't be there like answering these questions every day, every hour. So I will be checking these maybe once a week if you have something you wish to know. But yeah, be sure to check those out. So let's continue with the actual topic of today. So this is our session for the first day. So today I will be giving you an introduction to building LCA and also the software training as mentioned. So we will go through introduction to OneClick LCA, then talk a little bit about climate change and construction, then dive into the world of LCA. So is LCA, what are the building LCA stages? Also, what is an EPD? So important terms there. And then a short look into legislation and standards. And then, like I said, the demo. So how to create your account, how to access, and then a look into the actual software. And in the end, there will be some question and answer, time for question and answer, and also a self-study assignment. Obligatory though, so it's not, you don't have to do it, but something that you can do to improve the level of your knowledge. On Thursday, we will continue with reducing emissions in practical projects. So we are checking how to perform building LCA at an early stage design. So for this, we will be using our Carbon Designer 3D tool, and also go a little bit through the optimization of these kind of baseline results to get the best results we can. And also we are looking into the result interpretation and other aspects related to that. But today we will start with the introduction to OneClick LCA. So who we are. Our mission is to power the makers of zero carbon future. So this means that we provide the necessary tools and training to enable the change makers such as everyone who is listening today. So it is you that will be making the zero carbon future for all of us. OneClick LCA is the world leader in construction and manufacturing LCA software. So we provide tools to conduct LCA for buildings, materials, infrastructure, and also we have ways to do this greenhouse gas accounting for company portfolios. The idea of OneClick LCA is to make life cycle assessment easy, as in you don't need years of training to learn how to use it. So what you need is basic understanding of the construction industry, construction materials, and the software will then guide you forward. And here you can see some of our customers. So we aim to connect the entire industry from engineers to architects, manufacturers, builders, investors, to institutions, to whom we provide a global platform for data and tools to make calculations in compliance to certification schemes and regulatory frameworks. So OneClick LCA is a global platform that supports over 60 different certifications and regulatory frameworks and includes the world's largest data bank of construction materials with over 150,000 data sets. And we provide building information and building energy model integrations for all design stages. So you can see some of our integrations shown here. Maybe some of them you might have been using before. And finally, OneClick LCA provides free training for everyone interested. We provide reports and policy work and research articles on meaningful matters. And lastly, we are a team of experts ready to support you in your journey to decarbonization. But now we dive a bit deeper into today's agenda and continue with a look into climate change and the role of construction industry. So here you can see a graph showing the situation as of now. So as of 2022, the global greenhouse gas emissions reached 58 gigatons of CO2 equivalent, which is the largest ever recorded. And the already implemented policies, which you can see here with the blue line, so they are leading us to a world where the climate is on average 3.2 degrees Celsius warmer than the pre-industrial reference period of 1850 to 1900. So the nationally determined goals, or the NDCs, or nationally determined commitments, set under the Paris Agreement are not even close to closing the gap to 2 degrees, but countries are off track to achieve even the globally highly insufficient NDCs. So the current commitments by countries as expressed in their unconditional and conditional NDCs for 2030 are estimated to reduce global emissions by 5 to 10% respectively compared to current policies, assuming that they are fully implemented. So to get on track for limiting global warming to below 2 degrees and finally to below 1.5 degrees, the global greenhouse gas emissions must be reduced by 30 to 45% respectively compared with current policy projections. That is quite a big thing. And restricting the global warming to 1.5 degrees requires approximately 35 gigatons of carbon dioxide equivalent of additional reduction measures. So this is no small feat. And in terms of construction industry, well, buildings are responsible for nearly 40% of global carbon emissions. So about 3/4 originate from the operational emissions, while the remaining 1/4 is from materials and construction activities. So this 11% entails the embodied carbon we are then next going to talk about. And until 2060, the global population is expected to grow by nearly 3 billion people. And basically all of it is expected to happen in the cities, meaning that a huge amount of floor area needs to be built. So it has been predicted that cities will actually double in the next 40 years, which will create up to 200 gigatons of embodied carbon from construction materials only. And what this means is up to 3 years of global carbon emissions only from materials. or in other words, it means building a New York City every month until 2060. So for this reason, the World Green Building Council has stated that we need to be cutting embodied carbon now. So it follows that all construction needs to be operationally carbon neutral and create at least 40% less embodied carbon by 2030. So it is quite obvious that the construction industry needs to act fast. So, and then just a reminder, when we talk about embodied carbon, we mean the greenhouse gases embedded in the materials. So these originate from the material processing and manufacturing, transportation, the use of these materials, and the end-of-life processes as well. So if we look a bit closer to a building, so we can see where the climate impacts mostly come from. So this is an example building, which is a typical Finnish apartment building with 4 floors and a cellar, the floor area of 3,000 square meters, and it's assessed with the Finnish assessment methodology, which is compliant with the EN 15978 standard, and is calculated over 50 years of lifetime. So these values are predominantly statistical averages from OneClick LCA projects. And here with the green bars, we can see that the biggest impacts are embodied. So approximately 44% of the building's life cycle emissions. In this case, they come from the A1 to A3 emissions, meaning the material emissions of the building. So it includes the material production and manufacturing impacts. And the next biggest emitter, with a bit less than 40% of the whole life cycle emissions, is then the P6 here. So this is the operational energy. And the next would be all the replacements during the lifetime, so P4, and then the construction site impacts as A5, and then the transport A4. Oh yes, and then there's also the stage C, so this is the end of life of the building. So if we then look at the issue on an annual basis, we see that there is an important emission peak at year 0 when the building is built. So this peak entails the material manufacturing impacts as the high blue column, with the transportation to site and the construction site activities as smaller entities. So with the pink columns, you can see the material replacements that add into the embodied impacts, while the operational emissions are divided evenly throughout the life cycle of the building until the end of life of the building. So we do know that the energy sector is actually decarbonizing. So the share of renewable energy increases and the fossil fuel use decreases, and thus the emissions from the energy sector are going to become smaller as time proceeds. But the emission peak coming from the materials remains unchanged. So, as we said, the materials will become the dominant source of CO2 emissions from buildings in the future. And as we saw, the operational emissions from energy still form about half of the life cycle emissions, but this share may be already as small as 10% in the modern passive houses. The average material emissions are also exceeding the operational ones already in some countries. So, for example, in Norway, where practically all electricity is generated by renewables. So in the case of Norway, it would be hydro energy. So on the journey to holistic carbon management, embodied carbon is simply the next level in decarbonization. And although we are getting ourselves deeper and deeper into like the whole global warming mess, there is also an ever increasing demand for carbon neutrality in the market, and the need to make changes also in building sector is getting ever clearer. So in that sense, we're in a lucky situation as LCAs and embodied carbon management is becoming a norm and therefore required by businesses, regulation, and certifications. So just being less bad no longer cuts in the market. So you need to actually be making changes. And as of now, there are over 100 certification schemes and regulations that drive the life cycle impacts of construction projects and materials. So building LCAs, climate declarations, material documentation is being required by customers, investors, and also nations worldwide. So That was our look into climate change and construction. And next, we move on to talk about what exactly is LCA and how you can begin to implement it. So LCA, or life cycle assessment, is a holistic approach to environmental impacts of a project. So it avoids shifting of burdens from one life cycle stage to another by addressing all stages, and provides the results in a way that makes it easier to implement desired changes to products, processes, and services. So how the assessment works, very much simplified, is that once we've set the scope and boundaries and assumptions, we get the material information, convert the inventory data into a set of potential environmental impacts, such as global warming potential or eutrophication. And when talking about greenhouse gases, embodied carbon or carbon footprint, we would get information about the different greenhouse gases listed here, for example. We would use a factor derived from IPCC characterization model, which is then applied to convert the life cycle inventory results to the common unit of kilograms of CO2 equivalent for the characterization factor of global warming potential in the impact category climate change. So here, the process can be done for materials or processes only, for life cycle stages, or for the whole life cycle of a building, such as here. And a bit more detail here. So each indicator, so the LCA outputs are environmental indicators, and each indicator describes a particular category of environmental impacts. And the impacts are expressed as quantities of matter that has potential to cause such impacts, but they do not represent the actual harm, which would then be the endpoint result. For instance, global warming potential represents the amount of CO2 equivalent gases released, but the final impact might be, for example, the acceleration of polar melt. Global warming, so here are some of the basic or the most common indicators used. So global warming potential describes how much a product contributes to climate change. So when LCA concerns only this impact category, it's also called the carbon footprint. In other indicators include, for example, acidification potential, which describes how much product acidifies the environment, which may result, for example, in acid rain. The eutrophication potential describes the flow of nutrients to ecosystems, for example, to water bodies, resulting, for example, to algae growth that then depletes the oxygen in bodies and causes deaths of animals. The ozone depletion potential describes the damage caused to ozone layer in the stratosphere. And then there's also tropospheric ozone depletion, which describes the quantity of summer smoke causing gases emitted. And then there's also the depletion of fossil resources, which describes how much fossil resources are withdrawn from the earth. So if we then proceed to see how these impacts are calculated throughout the whole life cycle of a building, we must first get to grips with the standardized approach to life cycle assessment. So this graph here explains the EN 15978, or the Sustainability of Construction Works standard. So here you can see the different life cycle modules and stages included. So if we start from A1 to A3, which is the product stage, we would have the raw material extraction, transport to manufacturing, and then the actual manufacturing of the product. Then the material would go to the construction site. So we have the transport, A4, and A5 would be the construction site operations. So this includes the installation and assembly of these materials into a building. And then we have the use stage, or the stage B, which includes use, maintenance, repair, replacement, refurbishment, and also the stages B6 and B7, which are the operational impacts. So this includes energy and water use. And then there's the stage C, or the end of life, which includes the deconstruction and demolition of the building, transport to processing, and then the actual waste processing, and then the final disposal, for example, to landfill. And on the outside of this whole thing, we get module D, which is the benefits and loads beyond system boundary. So this would include the reuse, recovery, and or recycling potential expressed as net impacts and benefits. If we look at it a bit more detailed, so this is a more common representation of a building's life cycle stages according to the EN 15978 standard. So here you can see the same stages and modules as in the previous slide. So from A1 to C4, and also module D here separated. So this is quite important to notice that the module D is always supplementary information beyond the project lifecycle, and it's never benefits are basically never deducted from the actual impacts, so they are only declared separately. So current regulations usually focus on this part, so operational energy use. So this is regulated all over the globe. So for example, in the EU, we got the energy performance directives guiding us. But if we go to the actual materials, so we got other assessment types. So for example, the assessment that only considers the initial material impacts is what we call a cradle-to-gate assessment. If we add transportation and construction impacts, we would then have cradle-to-practical completion assessment. And when considering also the use and the end-of-life impacts, we would have the cradle-to-grave assessment. So this is the most typical approach for a building LCA. So if we bring in module D, we can call this a cradle-to-cradle approach, and this is where the circular economy comes in, because we are taking into account also the reuse and recycling and so on for the materials. So nowadays we're aiming for these kind of assessments because we want to increase circularity within the construction sector. And also the product LCA should also now report the module D for declaring the recycling benefits and loads as well. If we leave out the operational impacts, we would have an embodied carbon assessment. So this would be only the materials. So what is the appropriate time to conduct an LCA assessment? So the answer is sooner the better, as the decarbonization potential actually halves after each project stage. So you need to start working on it early on. So changing the project direction comes increasingly difficult and costly when the project progresses. So this limits decarbonization potential as well as the ability to influence specifications. Cost increases as the ability to influence emissions decreases. Then let's go into EPDs. So what exactly is an EPD? So for LCA, we know that data is key and you need the data to be reliable. So what you would most often turn to is an EPD or an environmental product declaration. So an EPD is a document that basically holds the life cycle assessment for a set material or product. EPDs are externally verified and standardized descriptions of the environmental profile of any product or material over its lifetime. So it helps to transparently communicate the product's environmental impact, providing a summary of cradle-to-grave emissions. And EPDs are also type 3 environmental labels based on international ISO and European EN standards. So why are EPDs useful? Well, they are objective, so they are basically they are based on internationally accepted standards and validated LCA methods. They are credible and neutral. So EPDs are critically reviewed, approved, and maintained by independent third-party verifiers and they do not make environmental preference claims. EPDs are open, so they are free for everybody. They are applicable also to a wide range of products and services and can be easily accessed. EPDs are environmental impact oriented. So while an EPD doesn't mean the product is not necessarily good or bad for the environment, it does assess the potential environmental impacts, and having that information is, well, required to make an LCA for a building. EPDs are also instructive, so they give general information as well as explain terms, definitions, and LCA concepts, and they help to interpret that information. So in a nutshell, EPDs are based on real data. There is no forecasting of future impacts. They can represent either one product and one factory or many products and many factories. They are often valid for 5 years. There are several kinds of EPDs that represent different scopes. There's cradle to gate, cradle to grave, and then cradle to gate with options. So the EN 15804 plus A2, which is the European standard for EPDs, mandates the use of cradle to gate with options, or preferably cradle to grave plus module D. So just declaring these modules A1 to A3 no longer suffices for new EPDs. And this is already in action. And in a couple of years, the old type EPDs that only publish the cradle to gate impacts will be obsolete. And then EPDs offer knowledge on the product's environmental performance, and only similar products that are calculated with same methods can be compared. So here's an example of an EPD. So here it tells us what standard it refers to. So it's made in accordance with this older version of this EN 15804, and also ISO 14025, which is the international standard. It gives us the date of issue, tells us the validity, and then also when the validity ends as a date. And it gives us a statement on the verification. And this is what it would look like on the inside. So the report basically shows environmental impacts for each life cycle stage and module on chosen impact categories. So here you can see the stages, so product stage, construction stage, use stage, and so on, and also separated by modules. Here you can see the chosen impact categories. So we got global warming potential, ozone depletion, acidification potential, and so on. And it's also instructive, so it tells us what it is actually measuring. Then we'll continue with a quick look into legislation and standards. So LCA follows standards. That's what we covered so far. So it is a standardized method to assess the environmental impacts. So the cornerstone standards for LCA are the ISO 14000 family. So we got 14040 and ISO 14044. So these are basically, they are the standards for the fundamentals for LCA. So they are used in all industries and in professional context almost all the time. Based on these, we have the construction work specified standard. So the EN 15978 that was mentioned a couple of times. So this is the LCA standard for construction projects. And also the international version, the ISO 21929, and also the ISO 21931. But these are not used in Europe usually. But if you are located outside Europe, these would be the standards your LCA is made according to. And then we have also the Environmental Product Declaration of the EPD standards. So there's the international 14025, which is the cornerstone standard for all kinds of EPDs. And then the 15804 and the EN 15942, which are for the EPD data and EPD format in Europe. And then there's also the ISO 21930, which is hardly used in Europe. But again, if you are located outside Europe, this would be your EPD standard. And this is a graph on the structure and a structure of accounting principles and standards. So towards the bottom here, the level of detail increases. So on top, we have the ISO parent standards, so the life cycle assessment standards and also the sustainability indicators standard. We have the EN standards, which are, again, like tailored for European processes. So we have the environmental performance of buildings and the environmental product declarations. And if we go further down, we get national regulations and voluntary environmental certification schemes that are all based on these standards. So for example, levels is the European framework for sustainability of buildings. And then there's also these commercial certification schemes such as BREEAM and LEED. And just as an example, there's also the Finnish YM method for low carbon construction, which is based on both levels and then these EN 15978 standard. And so just a quick look into the key requirements in the EN 15978, which is the standard that you will be following here in this contest. So for this architecture contest, you will be granted access to our software, and the tool we have chosen for this assessment is Levels. So the EU Levels framework provides a common language for assessing and reporting on the sustainability performance of buildings from multiple aspects. And then one of the core indicators is life cycle environmental performance of buildings using life cycle assessment. So as we've established, the Levels is based on this EN standard, and the key requirements are summarized here. So required service life is set based on property owner's requirement. So the materials must be replaced if they fail to perform for that lifetime. So this is always calculated. The functional requirements must be clearly documented. So comparison is only possible for comparable performance. Construction products are only comparable at the building level, so there is no comparison without taking into account the building context. So for example, one product might require more maintenance or replacements over life cycle or require additional other materials. So you cannot be just comparing like apples to pears, but you need to know the functional equivalent at the building level as well. And there will be no forecasting, so you are not allowed to take into account any potential improvements that might happen in the future. And you are not allowed to calculate LCA with the use of market-based green electricity because it's impossible to guarantee in the future. Then we've concluded our quick introduction to the world of LCA and what you need to know before you begin, what kind of data you can use, and what are the main standards regulating the process. So before we continue, sip of water. And maybe if I get to check the question and answer. There are no open questions. Feel free to type them here if you have something to ask. Colleagues might answer your questions, or we can also answer them in the end of the session. So let's continue with the basics. So how to create your account. So first, as said, we have included the Levels LCA tool, but we have also included the Carbon Designer 3D for early state assessment. And I will take you through Carbon Designer in the next session. So now we'll just concentrate on the main OneClick LCA application. So here I've added links, so you can also click here and see our help center articles. So you can, if you want to know more about this Levels lifecycle assessment, you can check what it includes, what is the scope, what kind of building parts we include, what kind of level so levels means that there's different levels of assessment, what is included in each level. Also the inputs, what we need to have. And also, yes, same works for Carbon Designer. And also I've included this circularity tool, which allows tracking, quantifying, and optimizing the circularity of materials, because the circularity is emphasized in your assignments or your contest description. So be sure to check these out as well. So to begin using the software, you need to register and activate your account. So what you need to do is go to OneClickLCA.com. And well, this is what it looks like, so I can just show you. If it wants to load, yes, so this is our main page. And what you would do here is you would log in. Let's see what happens. Okay, so I'm already in, so it takes me directly here. But for you, it might ask if you are a new user and to register here. So fill in your information, activate your username from the email you received, and then log into the platform. So remember to check your spam folder if you do not get the activation email. So this is a common problem, that it goes to spam and then people get confused like as to why they cannot activate their accounts. If you continue having issues, please do this again. Check that you have typed in the correct email address. But if you still persist having issues, so you can send me email directly and we'll try to fix it together. Once you've done this registration and activation part, you need to create a building. Oh yes, so sorry, you have to register and then you need to log in, create a building, and then you can activate your license basically. So here you can see if you go to the new project, you can enter the license key here. So basically what it would look like, let's see. So go to OneClick LCA, we log in, you have typed in your information. You would then go to add a building, and then in the building, you would have access to this kind of so you will get to create a new project, and here you can enter the license key, and then you can start doing your calculations. So I will show that in just a moment. And yeah, then once you've done all this, you can create your first design and set your LCA parameters. But this is exactly what we are doing next. So I hope that you will now forget about the registration for a moment. So unless you have done this already, because now we will proceed to the software demo part. And what I would like you to do is follow it rather than try and do the same thing simultaneously. So the recording will be available from tomorrow, and it will be easy for you to return to whatever points of concern you may have to check the inputs and overall familiarize yourself with the application. So if you just concentrate on following what it looks like now, then this would work fine, I think. Okay, so what will happen now is I will actually go into the software. Let's see. All right. So first, I suppose we need to zoom in a little bit. Okay, so this is what the main page will look like. It will show your projects in the front page, but there's also public demos that you can go and check. You can click them open and you might see, for example, how the materials are arranged and what kind of like units you might use for certain type of materials and so on. So you might want to check those out. They can be helpful. So as I said, all right, yeah, before we go in, I can show you that from your user account, you can also alter your profile information. And here, something important. So if you want to use another language, you can. Just as a note, these other languages than English might not always work perfectly, but if you want, you can use your use the software in different languages as well. So we go add, and we want to do a building. So like I said, you need to enter the license key. So the license key was given in the presentation. You can also find it in the Academy site. So there's the introductory lesson that also tells you the license key. So you can find it in several places. So you need to add it here. I will just copy it from my notes. So what you would do is you paste it here, click activate, and it says that it's found a license for this student contest. And okay. Okay, so then it shows us what are the mandatory points. So we need to add a name. I will make this demo project. It asks you where to put it, so just leave it on the main page, I suggest. Then it asks for the building type. So if the building has several types, choose the most suitable. But I was thinking that we go for apartment building. So this could be your new build assignment. Country, you have to put it here, but it's chosen Finland based on my previous inputs, I think. So this is important for the localization. It asks for the address. You might want to put it in if you know it, but it's not necessary. So if you click next, it will take you to the optional information. So everything on this page is basically optional, so you don't have to put in anything. If you put in the gross floor area, it helps you with the calculation. So because it like takes it directly into the calculations from here, but you can also add this at a later stage. I will just put 3,000 here because this is my building and I want it to be this big. And my building has 4 above ground floors. Again, this is optional information. The frame type. So you can choose it from here if you know what it's going to be. If you're making several designs in your project, you can just put not determined or not sure, because you can always set the frame type per design later on. And there's also other kinds of additional information that you can put, but these are a bit more specific, so probably not applicable in your projects. So then we just click next. Okay, so this is our project main page. And in this project, we can start adding designs. But before that, we need to choose the calculation tools and set up calculations. So this helpful finger here is telling us what to do. Before that, also I'll show you that you can add users if you want more than 1 people on the project. And there's also more actions. So you can, well, this is not probably something you want to do at this point, but from the modify part, you can, for example, change the initial inputs. But what we will do is we will get started. So these are the available calculation tools we have added. So there are 2 levels lifecycle assessments, and these are the EN 15804 plus A1 or plus A2. So plus A2, like I told you just before, is the new standard to which all the product EPDs must be done according to. But since they are added into the software, not instantly, so there's not also that many of these yet, because because the old EPDs that are made according to plus A1 are well, they are applicable a couple of years more. So there is much more information to be found in the plus A1 tool. But if you want to look what the plus A2 would look like, you can go and choose that as well. And you can also choose these tools at a later stage. But here I would suggest you choose A1 and also the building circularity tool. Then we get next. And now within our project, it asks us to create a design. So within a project, you can have several designs. And our design will be, for example, Saint-Gobain apartment demo. You can add additional information and also choose the stage of construction. So of course, the earlier you start to do this, the better. And this, you can choose anything from strategic definition to in use, but as we are making a quite an early state design, I will choose this 2, which is concept design. Again, it asks us what tools we want to use, so we have these selected. Then it wants to know the scope, so it's predefined levels because that is what we chose. And the project type can be chosen from here. So for example, if you are making a renovation, so for your contest description, there was also refurbishment and renovation to be done. So you could choose that for them. But as we are calculating the apartment building, I will add this new construction here. And again, it's asking us about the frame type, but I'm not sure about that yet. So I'll leave it like it is now. And finally, it asks us to include the parts we want. So check all applicable. And because we are making a whole building assessment, I will choose everything here. And then click next. And then the next step is the parameters. So what you can do is use default LCA parameters. It's a safe option if you are not sure what to do. But because this is a demo, I will take you through like all of the LCA parameters we have here. So we will go to review and adjust. And the parameters is something that you can set now or go with the default, and you can always change them later. What it does, if you change them later, is that it calculates all the designs in the project. So what you do affects basically everything inside the project. But it's always, you are always able to choose what to do. So the material impacts are calculated with certain service lives. So that is our first part. And this is a mandatory section to choose. So the service life calculation rules can be changed here, but you can also always override this by manually changing the number in the building materials query later on when we go inside the design. So here, the default is technical service life. So it assumes that same types of materials have the same service life setting, which is the average for this type of material in good conditions. And then we have the commercial service life setting, and this should be selected if we don't have a good condition. So for example, the material is expected to wear sooner than its default service life. So this kind of like unfavorable conditions can be expected to happen, for example, retail buildings or like hotels. So where especially the interior materials are replaced more often. And then we have the product specific service life. So that this means that the service life value is taken directly from the EPD, as the value may be dependent on the manufacturer. Sorry. Yes, and yeah, the generic materials will still use the technical service life. And finally, there's the RICS default service life, which uses the value specified in the RICS guidance, which is widely used in the UK, but usually not outside of UK. So for this project, as we don't yet know what kind of materials we're using, it's okay to go with the technical service life. If you are using more EPDs in your project, I would suggest you go with the product specific service life. But here I will just keep with this technical service life. The next part is transportation distance for materials. So you can choose the typical transport modes and distances. And since our project is in Finland, we will choose Nordics. There are other options as well, but Nordics is a good place to start. And yeah, this is all something you can always choose to alter later, or you can also change the individual data points manually when editing the designs or when you have more detailed information, for example. Then we have the material manufacturing localization method, which has several options. So this is basically when we have limited information to work with, we can use other data that is localized to our country where we are working in. So the product manufacturing impacts are largely defined by the energy profile of the manufacturing country. So you can select here a compensation factor to adjust the impacts of manufacturing in another country. So for like it would have been made in this country. So basically it takes the local grid energy mix and adjusts to that. So for Finland, this might be, for example, coal, renewables, nuclear, and wind. And for Norway, it would be mostly hydro, for example. So this is, it would then change the manufacturing emissions based on that. So this basically solves the issue where there are no data points for a material in the chosen location, and it helps you to get more representative results. So using this localization is not mandatory, but it's recommended for cases where the materials are sourced from a region where the local data has gaps. And also for certain certificates, such as BREEAM, you are required to do this. And it is also used for all the OneClick LCA generics, regardless of parameter settings, unless you specifically disable it. But we will go with the recommended settings. The material manufacturing localization target lets you choose the electricity profile you are using. So as we are in Finland, we will use Finland, and there are several electricity profiles here. The benefit allocation method is important for the Finnish assessment methodology, but here you could, for example, choose the Statistic Finland electricity profile. And then end-of-life calculation method. So this allows you to choose what happens to your materials once the building is demolished. So there are a couple of options. There's material locked. So this is defined by material type. Market scenarios. These are user adjustable, and the default option is chosen based on the standard practices of the market. And then there's also EPD, end-of-life scenario, which is also user adjustable. But this is taken directly from the EPD. So this allows you to choose what kind of benefits we get in the D module. So if you choose this one, you will get to choose also like what happens here. So for example, if wood is incinerated, the energy from it goes to district heating system in Finland, and you can choose the energy profile here as well. But the market scenario for Finland is also that if the wood is incinerated, it goes to district heating system. So this is a default approach in Finland. Okay, but that was the parameters. If you want to know more, you can always click here. It will take you to the Help Center page. Also, you can see some more specific guidance here, for example, for the manufacturing localization method, which is quite interesting. So if we click here, for example, it tells us what it is, how does it work, and so on, and a bit more specifically on the calculation methods. But we are happy with these. I will click Save. Just checking that there is one question. Once finished, is it possible to have the registration of the course? So yes, I will take you through it once more. And you should have had the email when you enroll to the course. And in that email, you have all the links that you need. And inside the course space, you will have the recordings where you will find all this information to review. Okay, but now, so now we can see that we have our levels life cycle assessment appeared here. So we have the units. We have no results because we have no data inside the design. So if you want to change the parameters later on, you can click here. Here you can add a design. If you want to make, for example, comparative design, you can choose to compare data. This is what I will show on Thursday. And on the tools, it shows you the available calculation tools. So you can add or take something out if you want to view here on this main page. But now let's go into that material query. So if you click this input data, small arrow here, you will get this drop-down menu. First, it will show you this view results, but it says that mandatory data is missing. So we have nothing in the design yet. You cannot see any results. And then it will show you the query tabs. So this is where you need to input data. And it also tells you with red which parts are mandatory. So you need to add building materials, energy consumption, calculation period, and building area. And then additionally, you can add water consumption, construction site operations, and emissions and removals. So I will first show you how this building materials works, and then we will actually import data using the Excel file. So here it again gives us a warning of mandatory data that is missing, and it shows the query tabs here, so you can see which are the mandatory ones. And we will go through them one at a time, but first let's take a look at the actual materials. So the building materials query is divided into sections. So we have the foundations, the substructure, vertical structures, and so on, and then sub sections with external walls, facade per section. So horizontal structures, other structures such as windows, external areas, and also then the building technology is separated here as its own section. So what we can do here is we can start adding materials simply by typing or clicking the arrow. So if we click the arrow, we can see all the different categories. We can click open a category and see all the different materials inside that category. So first, because we are in Finland, it will give us these Finnish points as local generic data. So use this when products are not chosen or the manufacturer has no specific data. So these generic points have been made by taking several EPDs and calculating an average value for that product, or maybe modeling these different kind of scenarios and processes. So these are quite reliable material sources, especially in the early stage design. These are very useful. So yeah, the local generics, and then it gives us the local manufacturer specific data. So here, for example, the Saint-Gobain ones also included. In these, it will also tell us a little bit about the material, the trade name, and also the program operator who published this EPD. So here, for example, it's EPD Norge. These little clouds here tell us a little bit about the performance of the material. So the redder, the worse, the greener, the better. So if you have a green material, it says that its environmental performance is better than the red cloud here. But yeah, maybe putting glass wool into foundations is not a good thing. So we will put some concrete in there. So here, if I type concrete, it will give us several different categories to choose from. If we go a bit more specific, let's choose a certain grade, for example. So we can use ready-mix concrete. So here I have, for example, because I am part of OneClick LCA company profile, it gives me these kind of company favorite materials that my colleagues have been using, but also the local generic data and so on. But if I want to compare, for example, I would like maybe to use this one with 10% typical recycled binders in cement. I can just add it in. put maybe like 1,000 cubic meters of that. I can add a comment if I want. So this is a, I don't know, manufacturer name or something, or this is sourced from this and there, and or maybe like some specific information about the material or the location where I'm putting it into. I can choose the building parts. So here it's actually, I am using it for, I don't know, retaining walls. The company classification is not relevant for you. The transport, so like I said, it gives us this default Nordic transport distances and also the means of transporting. So this is something you can change. So, okay, I know that it's coming 50 kilometers away, so I can just type 50 there. And it gives us a concrete mixer truck. Well, let's say that it's only half full, for example, so you can change it here. There's several different means of transport you can choose from. So yes, let's put 50% full. There's also the leg 2. So for example, if you have another a site, for example, and the concrete truck goes into two places, then you can choose here, like for example, the kilometers and the means of transport. So yeah, from these little question marks, you can always see a bit more closer information on what you need to put here. So it's very, like I mentioned, the software kind of helps you forward all the time. So here you can set the service life. For foundations, it's permanent, so it's not going to be replaced. The localization, as we talked, so this is a localization method for Finland, and there's the energy profile as well. So we are using the Statistic Finland electricity profile here. Here you can set the repair per year, so the B3 module. But as we are using this for foundations, it's probably won't be repaired, so we don't have to add anything here. But for example, if we had like windows or, I don't know, floor finishes, you might expect a certain amount of it to break on an annual basis. So you could put like maybe, I don't know, 0.5% here, and it will then calculate it for the whole life cycle of the building. The wastage, it's usually default. You can choose to change it if you have better information, but if you don't, it's fairly safe to go with this. And then the end of life process. So we chose the market specified end of life for the materials. So the market here says that the concrete is crushed to aggregate preferentially. Also, if you're reusing material, you can click this one. So for example, if we have a building that's refurbished and you want to include certain materials that are, like, for example, in the place. So for example, if you're using the old foundations of the building, you're not demolishing entirely, you're leaving something there, you can click this. And if it's not transported, you can also put this to 0. So if you're using it at place. So now that we've added this, we can click save. So remember to save often, because otherwise it won't calculate your impacts. Also, there is no undo button here. So bear that in mind, so you can't go back. All right, but now it shows us that we have 309 tons of CO2 equivalent. So this makes up 100% of our building, because we don't yet have anything else here. But then we have concrete. We also want some rebar into it. We can go to the change option. So there are alternatives we can do for the material inputs. So we can copy it, we can split it, we can replace it, or we can lock it or delete it. And if we lock it, this is quite useful if there are several people using or working on the same design. So this prevents from anything accidental from happening. So you might want to lock it, and then it can be unlocked whenever desired. But yeah, so what I will do now is I will split this. So we know that we have 2%, for example, of rebar in our foundations. So we have the concrete here, and we want to add some rebar into it. And let's put, for example, I don't know, the first one we get, so 60% recycled content. And we know that it's 2%. So we have 98% of this and then 2% of this, and it will automatically change the quantity to correspond to the share. We can then save. All right, and we can see that our impacts have changed. So we are actually 59% of our impacts is now coming from the concrete, and 41% is coming from the reinforcement steel. Here you can change the unit. So for example, steel, you might want to use, I don't know, kilos, for example. So it changes here, but now you can see that the impacts have disappeared. So you need to save it again. And so, and then if you remember, my steel had 60% recycled content, and I would like to reduce the impacts by replacing it with something else. So with the replace function, you don't need to type in any units or like material quantities, but you can just replace what you have. So I want to add reinforcement. So this is what we are using now, but I want to use this one. So it has 97% recycled content for the same strength. If you want to compare them a bit more closely, you can check the environmental profile, for example. So here we can see that the old one is 1.4 kilos of CO2 equivalent per kilo, but here we only have 0.5 kilos. So it's a better option to do. I will click save. And now we can actually see that our impacts are decreasing a little bit. Yeah, one more thing, from this green question mark, you can always get the data card open. So here you can get a bit more detailed information on the actual material, the description, how it was made, some technical characteristics, environmental profile. So this is useful for the comparison. And then default scenarios and assumptions and so on. And this is something that you can also do from here. So if you are interested in this reinforcement steel, for example, you might want to open several of these side by side, and you can just check like which one is best suited for your uses. Yeah, but now as I actually noted that time is getting closer to finishing, so I will actually show you how to do the import process and how we can actually get more data in here. So you can do it like this, that you just add row by row. But what you probably will have is, so first save. What you probably have is some material information in another form. So if we go back to the main page, there is no, you can see that there's no results because we have missing mandatory information. But what we will do now is we will import material information from Excel. So like I said, there are several ways to import material information. So you can use these integrations. So for example, if you're using Revit, you can get the material information and you can choose to do OneClick like a LCA in cloud, which will then import the material information here, and then you can calculate your results. I am doing this now with Excel, but the process is very similar to what it would be, like, for example, if you're using Revit or something else. So I chose import. Here you can click on help and it will take you to the help center article. So we have these templates actually here in the bottom. So these are the templates you would be using. So here is, where is it? OCL import form building metric. So this is what you would be using if you're using metric information in for a Finnish project, for example. So you can get that from there. I have a file ready. So I just uploaded it here. I will then click continue. And here it shows the path of bringing in the data. So it combine and mapping are clicked here as review manually. But because I want to show what's going on in each stage, I am choosing all of these. So it says that I'm importing 25 rows. Here I can choose where to put it. So choose the project. So it's my demo project, and choose or create a design. So this is my apartment demo. You can also choose to put this into a new design, which will then appear side by side on the main page. Choose the tool. So we are using levels and filtering settings. So here you can choose to bring only a part of the building structures. So for example, for lead, you would only bring structure and envelope, but because we are making a whole building assessment, we are bringing all data. And there's only that rebar and concrete in my design, so I can choose to replace the existing data, but I could also add to existing data or only update the quantities. So you can do this also by bringing in the same Excel basically as before, but only with updated material information or quantities. But now I'm replacing. You can also download the Excel at this point. If there is like connection issues, for example, you can send the data to another user, or you can continue. So now it wants me to confirm overwriting the data, but I will choose to do so. So first, it tells us to what's going on here. So it classifies our data. This is the OneClick LCA classification, and this is the classification assigned to my data. So it's putting them into foundation, external wall, and so on. And here it tells us what is the target location as well. So one thing to bear in mind is that beam actually means horizontal structures. So this is just a naming convention. This is fine, and we'll continue. Then it asks about filtering. So we should select the data to import, but because we want to do the whole building assessment again, we are choosing all of these. And it also tells us the amount of data points in each section. So we'll continue. And then it asks us how the similar data points are combined. I have no such data here, but if I had, for example, several rows of concrete that appears similar, the software would detect it and asks if we want to combine them into a single data point, because we want to keep the maximum limit. The maximum limit of data points is 500, so we want to keep the amount below that. At the moment, I have 24, so I have no issues. But if you have a large project with that is quite far along, you might have several data points, and some of them you might want to combine for calculation reasons or for efficiency. And you can choose what is the grouping criteria for this. So I have nothing here now. Click continue. Oh, I could actually show you what the Excel would look like. So a little bit about the naming. So this is my Excel that I'm bringing in. So yeah, this is what it looks like. So there's a class, there's the material, the quantity type, comments, thicknesses, and then transport distances, these kind of organization-specific classifications and waste and so on. The most important parts are the class and the material. So the class was how we did the classification. So these are the OneClick LCA classes, so foundation, external wall, column, beam, and so on. And the material name. So for material name, you want to be specific, but not too specific. So if it's too general, you might not get a hit. So it probably won't map it correctly, or if it's too specific, the same thing happens as well. Leave out like colors and such, you don't need those. But what you would need, for example, for concrete, it's valuable to know that it's ready mix, we have the grade, and we have the amount of recycled binders, for example. And the quantity type here. The comments are pretty good when you're bringing in data. So if it doesn't recognize the data or map it properly, you can write it in the comments and get it visible after the import process, so you can remember what materials you were working with. There's also quite a lot of these. So for example, transport distance YM is specific for the finish tool, and there's also other parts here that you can just leave out. But these are the most important parts that you need to consider. All right, so now it brought our data in and it's reviewing it. So there's a model checker that tells us if there are any issues in the data set. So we can click it open, and it's telling us that there is implausible thickness for some materials. And it recommends us to check or correct the defined thicknesses. So if I scroll down, everything is fine, but then there are these three little warning triangles, and it says that the door, for example, is implausibly thick. I doubt it. It's 10 centimeters thick for a metallic fire-rated door. So I'll leave it as it is. But then there's also these warnings for steel rebar. So it's marked as 4 millimeters, and it says that it's actually implausibly thin for material of this type. But I am quite happy with this, and this is something that can always be changed later. Otherwise, my materials seem to be in order. We can continue. So next, what it does is it does the mapping. So because I'm using OneClick LCA data points, it has identified all of my data. But even if I'm using these data points, it sometimes doesn't identify them, but you need to do this import process a couple of times, assign the material to the correct material. So here you can choose what this is. So for example, ready-mix concrete, it maps it as ready-mix concrete. But it's a bit specific one. So it has 70% of GGBS content in the cement. So if we want something other than that, we can alter the mapping here. For me, I'm happy with this one. But I will show you, for example, I have a very, very general material here. So I have floor screed, for example, and it has assigned floor screed, this German data point for it, and I'm not really happy with it. I could find another one, or I can decide later. So if we click design later, it will import it as an undefined material, and I need to then assign the material for it in the actual software or the interface. So this is what I'll do with the floor screed, but otherwise I am okay with this. So I will then click continue. And we'll see what happens. Okay, so it takes us directly to the results, but we will go back to building materials. So from this input data part, you can click and go into different sections. So everything that we imported is here now. There are also some constructions. So for example, where could I say, for example, external wall is a construction that includes different data points calculated like beneath one group. Here is our undefined material. So this was the floor screed, and I want to replace it with something else. So I need to go to change, and I will replace it. So if you use the replace function, you don't have to type in any numbers, but you can just replace it with the material, the quantities remaining the same. So it is a leveling screed for floors, and I want to use this this Weber floor screed to replace it. So I will choose that one. It shows me what it is, and I'm happy with it. So I will click save. So this is how you would deal with materials that are undefined. So yeah, now I have it here. Great. Okay, a bit more about the materials. So if you want to add in something more, you can also use the filters. So here you can get the different categories. And as I mentioned, constructions. So for example, here the external wall or apartment construction. If you want to add these kind of ready-made constructions, you can also go here. Filter by country. So for example, for Finland, you can also choose data sources if you wish, the type, if you want a generic or manufacturer EPD, for example, upstream data banks. So you have the EcoInvent and GAPI, for example, not that useful maybe for this building LCA, but for material comparison could be. And then if you want to set the carbon intensity, also units or different properties. So if you, for example, want 100% recycled concrete or something like that. But I want these two. And let's see if I can add a foundation construction instead. Foundation construction. So we have here. So I want to replace my concrete and rebar with plinth and footing foundation for ventilated base floor, for example, with reinforced concrete piling up to 10 meters of depth. So I will add this. And this is calculated per square meter. So I have 3,000 square meters of building. I will actually delete these two. And also the EPS, because I believe that it's included in my construction. Yep, so you can see everything that goes in there calculated according to your area. And then you just click save, and let's see what happens. Probably the impacts will increase a little bit. All right, so yeah, it was but our building needs good foundations, so this is what we'll go with. And then we will continue. So we've gone through the materials, the import, and we can go through the energy. Except first, I will actually show you what the reuse will do. So for example, windows in our project are reused, and as well as the doors. So they are brought in from another construction site, for example. So they are leftover material. So they are basically considered as reused. So I will click on those. If I then click on save, it should also reduce the impact a little bit at least. All right, so we got almost -7%. So this means that we are saving on the product stage emissions. So we don't have to calculate those because they are already calculated for that other project. So here we are only accounting for the transport, installation, use, and then the end of life. So this reduces some of our impacts. But yeah, let's move on to energy consumption. So I believe that for your projects, you need to calculate electricity or energy use overall. But once you have calculated them, you can just input the energy here as electricity, district heat, for example, and so on. So, yeah, you can just input these here. You can find what kind of electricity you are using. So, for example, we were using this kind of Statistic Finland electricity here. So we can just choose that one. There are also several other options. For this sized building, this might be an accurate number. Profile, yep, so this is okay. You can also specify the use if you want, but here I will just put overall. Fuels, if you have, for example, oil heating or something like that, you might want to put it here. But in Finland, in the cities, the district heating is what you would probably go for. So, for example, in Viki, this is what you would choose for a new building, this district heat. Or ground heat is also the other option, ground source heat pump. But we are using here district heat. And also, again, we can choose, for example, an average district heat. There are several like local options as well. We are going with the average, and for this size, it could be, for example, 90,000. Profile and usage also, so you can choose where it's going. District cooling is becoming more important also in Finland, so you might want to add something here. And also exported energy. So for if your building has, for example, solar panels on the roof, you have some leftover energy that is fed into the grid, you would put it here, and this would show in your D module. But now we are happy with our electricity and heating. Click Save. And then we go into water consumption. This is another annual query. So you would put an annual consumed water here. So here you have tap water, for example, conventionally treated. We might add this one, for example, as cubic meters. Let's say we are using, I don't know, 2,000 cubic meters. And then when you're moving along these query tabs, it also saves your results without you having to press save. So then the construction site operations. So this information is something that you would get from the company who is actually doing the construction operations. So they would provide you with data from electricity used for lighting, for example, machinery, and also the fuels for machinery, so like excavators and so on, and also the waste created. So you would put them here in their dedicated sections. But since we are doing an early stage assessment, we can also use scenarios. So this is made from average data that's common for that geographical region. So for example, in Finland, we have several different so we have machine operation and other site operation. So there's average construction site impacts in the Nordics per cross floor area. You can choose to do it with 100% biodiesel, for example, but we are just going with this one. And you would put the square meters of building as the quantity. And the same applies for the deconstruction. But for deconstruction, you, of course, don't have any data available until the building is actually deconstructed. So for this, you can only use scenarios. And in Finland, we have different data points for different types of buildings. So we would here choose the residential building and again input the number for the area. And then we continue to the calculation period. So this is of course important because often the results are given per year, so per square meter per year. And when you're using levels, you would put here 50 years. Then the emissions and removals. So this is something, so the emissions are basically only refrigerant emissions, so leakages. When you're using AC equipment, you would have a cooling agent, and those cooling agents, there's always some sort of leak, and it's specified by the material or the chemical you're using in your devices. So here you could choose what to put in, and also so the total, like the percentage per year, is given with the data point. You also have the emissions, the removals. So you have carbonization of cementitious materials and also vegetation carbon withdrawals that you can get then in your D module. So carbonization is something that happens to cementitious materials as they absorb carbon dioxide from the surrounding environment. So it's like a reverse of the calcination process that happens in the cement production. This depends on the total volume of these cement materials. So you can choose different kinds of scenarios mostly here. And if you're interested, you can also check out the calculations behind it. So it's actually quite interesting, but it's also a bit, it's very case dependent. So it's might be difficult to estimate. And same with vegetation. So you have different kind of trees that absorb different amounts of carbon dioxide from the environment. So this is something that you can use in your landscaping scenarios, for example. But I will just leave this blank because I have no better information. And then the building area. So this was an important one. So you put it tells you what to put there. So the gross internal floor area, basically. Oh, yes, I need to assign it. So yes, here. And then if we click save, we will be able to get a complete calculation. Go to results. And here we have our results. So now it's giving us these as scientific numbers. So the E is for exponent, but you can always change it here. So I will go with decimal numbers just for clarity. So it gives us the results per stage and module and per impact category. So here we have the global warming potential per kilos of CO2 equivalent for the construction materials, transportation, and so on, and then total and also per denominator, so per gross internal floor area per year, and also per gross internal floor area square meters for the whole life cycle. And also the different indicators here, so biogenic carbon storage. This is for wooden materials mostly. Ozone depletion potential, acidification, eutrophication, and so on. From the details, you can always check. So this is for the A1 to A3. So you can see your building materials, and it will then highlight the biggest impacts. So yeah, like foundations is usually what you would see here. So foundations are quite carbon intensive structures. And horizontal structures is another one. So you would see here flag with red the materials and what kind of percentage share they form of your overall impacts. So here you can also show numbers more detail, print these, or you can close it. And you can also click here, for example, transportation, you can see the different parts. So this is transport to building site and also the leg 2, which we didn't have. You can click P4, P5, and it will give you more detailed information on it. And for all these, you can export the used EPDs, you can change the result formatting, you can print the results, you can get a results report as Word, for example, send data to another user. And then you get indicators describing the use of primary energy and water for the same life cycle stages and modules with much detailed information, and also the site impacts. And then beneath you have the completeness and plausibility checker. So this lets you know if the analysis has been basically made according to rules. So here it says that mandatory elements are missing. So we are missing load-bearing structural frame, other systems. So we didn't have building technology, for example. And it asks us to please check if we have or are going to include these elements. But overall, we have a grade B. So this is based on the data that we have provided. And then it actually has these threshold values, and it's comparing the parts we are putting in to the threshold value, and therefore giving us a valid or an invalid answer. So, for example, I didn't have any roofing bitumen, for example, so it has no mass. The threshold value is here. But since we had a steel roof, we didn't really need any roofing bitumen. So we could just basically click this and this would be validated. Foundation mass is credible and so on. So these are something that you might want to check. They don't influence the calculations, but are more for your own information. Then you can click on the most contributing materials. So here it will list based on these A1 to A3 impacts the most influential materials. So for us, it's the ready-mix concrete because there is so much of it. It forms 28% of our cradle-to-gate impacts. And we can also here search for sustainable alternatives that might help us to optimize the results. So this is something that you might want to check. Again, with the question marks, you get the data cards, and you can also see the full ranking of all these materials in certain categories, and also to add to compare certain materials. And then in the end, it shows us the graphs. So a lot of information, and all of these can be also downloaded as images, or you can download only the information behind it to make your own graphs. You can get pies, bars, columns, tree maps. So for example, here you can see the global warming potential per life cycle stages, per classifications, the masses, and the resource types, for example. And you can also continue further to see different kinds. So here we see what are the most contributing life cycle stages in our building project. So we got electricity and district heating. There's also ready-mix concrete. And these are just there to help you begin to optimize. So you can look at this. You get all these different kinds of graphs that you will find something that works for you. For me, it will be the bubbles because these are very informative in my opinion. All right, so this was our quick look into the interface. So now we go back to the main page here. Here it will also give us information. You can click on the general information to remind you what we are doing. So this is our license, this is our address, what type, what size building. We can see the results and benchmarking. So we have this embodied carbon benchmark, which is based now because we are in Finland, is comparing basically these two all similar kind of types of projects made in Finland using OneClick LCA. So our project is doing quite well, but this is because we are actually missing some materials. So we didn't have those building services, for example, that are usually quite impactful. There's the embodied carbon by life cycle stage. So here you can again see where the impacts come from. So that would be materials, and also by structures. So vertical structures are, in this case, the biggest emitter. Then we got 10 minutes left. So yeah, first, if you would add a design here, you could maybe copy this and create another one and then start optimizing. But we'll actually look at this on Thursday. But if you do that, you would get like different kinds of results here, and then you can see which is the best one in terms of the chosen impact category, for example. but we'll look at that closer on Thursday. But I will quickly take you through the building circularity tool. So here we go in the building materials input. So this is the same. It looks a bit like the material query in the actual tool. But here you get to choose, for example, external walls for apartment. You get to choose if there is recycled content. You can alter them, update these values. If it's reused, so for example, we can say that our, I don't know, steel could be recycled or something. This is also related to the actual data points. So here we have 90% recycled, so it says 90% recycled, but if it's reused, we could also put a share here. We had those windows, for example. Let's see if they are, well, they are actually reused because we chose to reuse them. So we put here, it's 100% reused. Also, our doors were 100% reused. Oh, and you can also define the wastage, the design for disassembly here. So for example, a door could be easily designed for disassembly or designed for adaptability. So this is something that we will discuss a bit closer on Thursday. But we can now save, and let's see what our results will look like. So our circularity actually increased. It's a red number and it looks bad, but its circularity increased, so it's actually a good thing. Next query tab would be circularity score weighing factors, but this is probably something that you don't need to alter. So these are defined. So for virgin materials, the circularity would be 0. So we multiplied with 0 because these virgin materials get no circularity points. Then we had our calculation period, which was set for 50 years. And if we check at the results, we can see the building circularity score of our building. So it shows us the share of virgin materials that, you know, they get no scores. So this is actually 29% is the share of like these renewable, recycled, and reused materials, and also materials that are reused, recycled, used as energy. Maybe downcycled materials are not calculated in this one. So yeah, so this is something that you might want to check if you aim to reuse as many items as possible, so you can get this circularity index and maybe a closer look into what, for example, can be reused and recycled, and for example, these kind of design for disassembly and adaptability and how they would alter this score. But this concludes actually our demo. So I will now go back here. So we have only a couple of minutes left, and you have been very patient with me, and there's still quite many participants here. So next I will give you a self-study for session 1. So this is something that is not going to be checked or, you know, moderated in any way, but I do recommend you to undertake them as it complements the knowledge you will gain during this training. So the self-study for session 1 would be to research and document requirements of local or regional construction sustainability standards. So this is useful in terms of your contest description. And also there's some links to supplementary reading material, so emissions gap report, or the embodied carbon review, for example. So you might want to check those out if you have time and interest. And also I will ask you to familiarize yourself with the OneClick LCA software. So for Thursday's session, you would be able to ask if there is something that you find difficult or don't understand, or something just doesn't work. So we can also check those out. Or you can write them in the community. I can try and check what's going on there before Thursday's session. Again, the community page here. So go there, ask and answer questions that your fellow students might have. And now I will stop talking for a moment and see if you have any questions. So I will check the question and answer, and there is no questions. So I think everything was very clear then. If you have something, feel free to ask now, and I will see if I can answer it. So if you have something, please write it in the question and answer function. Otherwise, I would just suggest you to check the recording tomorrow. Refer to it if you have some issues. Check out the software, try to click everything possible, and just get in touch with it and try to familiarize yourself on different functions and so on. Everything basically is in our help center. So I provided you with several links. You can go also there and check it out. Just type a problematic thing in the search field, and you can find several articles and help center these pages that have a lot of advice and basically everything you need to know. And yeah, so the software is fairly easy to use because it has all these helpful links. So whenever you feel you're in trouble, check if there's a question mark, check if there's a clickable link, and it will help you go forward. There are no questions coming in, so I assume that you are more or less okay with whatever we discussed today. And yeah, otherwise, I think that we'll meet again on Thursday and continue with this exploration towards the world of LCA. So I will then now actually stop recording and wish you all the best, and we'll catch you later this week. So thank you.